Alright, Miss Howard's chemistry class. This is Unit 10, Heat and Thermochemistry, and this is PowerPoint number 8. And there's a lovely cartoon there for you again, and even teachers should not bow to peer pressure. Okay, so we're on capital letter D, reactions, on your notes. For a chemical reaction to occur, bonds have to be both broken and formed. That makes sense. You break the bonds of one substance, and you reform the bonds into a new substance. That making and breaking of bonds is going to release energy or take energy to do that. You know that bonds are formed in two different ways. You have two different types of bonding. We have ionic bonding, where the electrons are transferred, and we have covalent bonding, where they're sharing electrons. Don't forget that. Okay, every reaction has an energy change associated with it. So whether you're putting energy into it to get things to happen, or energy is being released, when the reaction occurs, they all have an energy change associated with it. Every reaction, every kind of reaction does. Some of them are big enough energy changes that you can tell immediately, and some of them are just tiny energy changes that you can't really tell without some type of instrument. Okay, so when we talk about bonding, if you break bonds, like you have the CO2, there's one carbon, two oxygens. If you break bonds, it actually requires energy. So you have to put energy into the system in order to get this to happen. And the opposite, if you create bonds instead of breaking them, you actually release energy. So when you take the carbon and you combine it with the two oxygens, you end up releasing energy from the system. So breaking bonds requires you to put energy into it. Creating bonds actually releases energy. You create something that's more stable ultimately and has less potential energy stored in the bonds, and so you have some energy released. Okay, so the energy is stored in the bonds between the atoms, and that's potential energy. So we have my lovely wrapper here. The chocolate is already gone. Oh, it was a very lovely Dove wrapper. And all that chocolate that was in there, oh, it left me a note. It says, "Your presence is often the best present." How precious is that? The Dove chocolate that's in there, that chocolate is made of atoms that are chemically bonded together, and you've got energy stored in that. And when you have stored energy, remember that's potential energy. Making bonds, again, releases energy. So when you put two atoms together so they're bonded, it releases energy. When you release energy from the system, it's exothermic. There's heat being released there. Breaking bonds, in order to get something to break, you have to put energy into it. Breaking bonds absorbs energy. It's endothermic. Endothermic, you have to put energy into the system in order to get those bonds to break. So here we have a lovely chart. So on the left, and it's got the reactants with the yield sign and the products. On the left, you have calcium carbonate. And since you're going to take that calcium carbonate and break it apart into smaller things, you have to put energy into it. So you look at the calcium carbonate, it's at the bottom of the chart, at the bottom of the graph, and you put energy into it so that the calcium oxide and the carbon dioxide together have more energy in them because you have to put the energy. It says calcium carbonate plus 176 kilojoules of energy. Where did that 176 kilojoules of energy go? It's in the bonds between the atoms. So in order to get this reaction to happen, you have to heat it up in order to get it to break apart. So breaking bonds takes energy. If you look, the reactants have less energy than the products that are up here. I don't know why that changed on its own. Okay, so now we have the carbon and the oxygen, and it's a higher level, and you're going to actually put the carbon and the oxygen together to make CO2, and it's exothermic. So your individual reactants had more energy in them than the products together, all together. So it's exothermic. How much energy did it give off? It's got it in the equation right up here. It gave off 395 kilojoules of energy. Breaking bonds requires energy. It's endothermic. Making bonds releases energy, and it's an exothermic process. Only one more PowerPoint section to go on this section, so that's the end of this one. Have a pleasant evening. No, don't have a pleasant evening. Pay attention and go to the last one.